Yes, so what I'd like to talk about today is technology transfer from the automotive industry into architecture and construction. Now, the question whether the automotive industry influences the architecture, we've seen too many examples today, I suppose. But there's often a question that relates to how buildings can be influenced by the automotive industry at the level of the innovation process, at the level of the technologies. And the answers in that field are a little bit less obvious. There's, some simplifying now, but there's broadly two schools of thought. Some people say the construction industry should look at the automotive industry and take as much as it can from it, because it's just more efficient. But at the other end of the spectrum, there's some who say, no, it will never work. It's a very different industry to start with. So how to get to this problem? I will use the example of glass as a vehicle of this transfer. So by saying that, I'm giving you the opinion that yes, there can be connections, there can be transfer between construction and the automotive industry. And the case that I'll present today is that this transfer can be quite close and quite, it can be a very good match when it comes about some building systems. So what I will do, I'll present you a visual journey, which I built up mostly from sources from the Libby Owensford archives, which is an amazing collection of company archives held in Toledo, Ohio, where the company of LOF, once it was took over by Pilkington in the 80s, donated an incredible amount of files to the local university. I traveled there a few years ago and I collected some data. Interestingly enough, it's not just about one company. That company also holds records of Pilkington and PPG of the same period. So it's a very interesting source of primary information. I also had a bit of a look at US patents to reinforce some of my theories. And then I'll present a case study, one building in particular, where we can understand how these dynamics happen. And I will start with glass, but I will end up probably more with methods of glazing rather than glass itself. So glass, now we know the material well enough, but there's one word that it's quite difficult to associate with the material, and that's the word safety. Can glass be safe? Well, it's not that easy. So the closest thing we have to safety glass is this invention, which took probably 30 years to get to this state. This is taken from a patent from PPG. It's what we call today laminated glass. Two sheets of glass that are held together by an interlayer of vinyl. And that vinyl, once it's put in an autoclave and put some heat and pressure, it can become transparent and it can bond sheets of glass together. So this is the closest thing to what we call today laminated glass, or in other words, it's probably the closest thing we can have about glass, and that it's also safe. So why is it safe? Well, it is safe because glass, ordinary glass, has a tendency to break in shards, and when glass is installed in cars, obviously, if it breaks in shards, it's extremely dangerous for the passengers and the drivers. So you can see here a comparison of an advertising campaign that was done in America for Libby Owensford by Floyd Gibbons, which was a radio commentator who also happened to have lost an eye, not in a car accident, but during the war, World War I. So it was a war correspondent who knew everything about danger. And so it was used in order to promote the idea that safety could be brought into cars, particularly as a result of having better materials, like safety glass, or in other words, laminated glass. So what is laminated glass? Well, two sheets of glass and a piece of plastic that keeps it together. It's all about the plastic. The glass could be done in different ways. Incidentally, during those years, the best product in glass was plate glass, which was extremely clear, extremely flat, so you could see through in a very clear way, as you should, through a windshield. But the plastic rendered the material somehow resilient, so in case of impact, it would not necessarily shatter and have debris inside the car. So these are some fragments of advertising from LOF. They actually had a fragment of the interlayer itself that the car manufacturers could take from LOF and then sell to the clients. And here you can see a test of of a ball that is thrown into the glass, showing this resilience. However, safety was not the absolute, as we will see. So manufacturers then advertised more the aspects of clarity. Safety glass was not all that matter. So in order to sell the product, they tried to promote the idea that you can also see very well through this glass. And this was mostly to do with the mastery that glass manufacturers had, particularly in the 30s and the 40s, in plate glass. In America in particular, they have extensive systems of glass manufacturing that had very expensive grinding machines that obtained extremely clear glass. So in this case, the Cadillac and LaSalle or the Chevrolet were incorporating safety glass, but the message was you can see through it better than the competitors. So the difference relied on the fact that glass of those days could easily have roller wave distortion, so unless it was plate glass and it was grounded. So you can see that the process of lamination, when you have small flat lights, a piece of plastic in between, and on the right you can see the effect you would have with plate glass, safety plate glass versus safety ordinary glass, which would have instead roller waves. We're talking about a time before float glass, so we sort of take for granted that the glass comes out of the factory with parallel faces. That's what we can achieve today after Pilkington's invention in the 50s. During the 30s and 40s, it wasn't that obvious. But glass we're looking at now is flat, as you probably noticed. So we're still in the 30s and the 40s. And there was a very interesting campaign by glass manufacturers in order to promote the idea that cars could be upgraded. So there was a very strong activity into promoting the idea that owners of vehicles, particularly during the Depression, should upgrade their windshields rather than necessarily buy a new car. So because glass was sold in flat lights, there was also manuals that were distributed to glass suppliers, so the lights could be cut to shape and used in order to upgrade the existing automobiles of the time. Obviously, the procedure was limited to sizes. It was also limited to the skill of those who could do it, and the glass lights had to be also ground on the edges. Then the war arrived, right? So in the 1940s, and in the 1940s, the glass manufacturers in America shifted a lot of their effort into aviation, tanks. They started to produce sort of plexiglass turrets. And one of the most significant efforts of the war period of a manufacturer like LOF was the production of canopies for bombers, for example, where like the nose of the B-29, for example. LOF produced some 5,000 of these canopies. He had a line that was dedicated just for that during the late 40s. This was glass. It was not plexiglass. It was safety glass. It was laminated glass, and it was bent, obviously, because it had to fit with the aerodynamics of the machines that it was going to go into. So what we see is that after the war, we suddenly have that know-how to produce bent glass. And whilst the bent glass that reached the automotive industry was not exactly the same that was used in the bombers of World War II, there was a conversion of plants, and there was a know-how into producing more and more windshields that finally had to be curved. The cars could be curved, and so glass changed as well. The idea of having standard flat lights was lost, and suddenly you had a custom approach to mass production, if I can use that contradiction in terms. So each windshield had to be designed specifically for a certain model. So this was part of a campaign that LOF, for example, launched to its suppliers, saying, well, you're going to have troubles because you're not going to have enough room to stock glass for replacement anymore. And they did that because they were saying to suppliers, don't worry, we will hold the glass for you. We will have our own stock. And so that if you're asked to replace glass windshields, we will take care of the cost for stocking it for you. So of course, car models adapted to that. The Ford Thunderbird, I understand, although I'm not an expert in car history in itself, was one of the first cars that used this curved windshield. So it's a windshield that is curving, is giving more view also to the sides of the driver. It also corresponded at the time, obviously, in the post-war when American families started to own more than one car. So there was also the idea that the car could also be not only for the husband, but also for the wife. So suddenly the market tripled, and so did curved glass. That was a windshield produced by PPG, the great competitor of LOF. LOF, of course, had its own safety plate again. So clarity, safety going together. I'd take your attention to safer, but not safe glass, because it was not safe. And in fact, it was found that the first laminated glass products, they were not sufficiently safe by present standards. So what would happen is that here on the left you see a car that had the first versions of windshields with an interlayer that was about half of the size of what will end up being imposed by legislation after the mid-60s. What would normally happen is that these windshields were designed in order to absorb the impact, but often the interlayer would break. So you see a comparison here with a car there, an accident where, by the way, that hole there on the right is the driver, which in America, by the way, sits on the left side. That was launched on the opposite side of the windshield. Of course, the seatbelts were not worn. It was the time when the seatbelt idea was still coming up. But even after when the seatbelts were worn, we still have this tendency for the drivers to be thrown around the windshield, so they could hit any time. However, you can see the difference between poking a hole through the windshield and bruising your head against it, which obviously would be a day to forget for anybody, but there was significant differences in the outcomes. So, and here is, by the way, it's another crash test dummy, the process illustrating this principle. Obviously, that on the left, that's the kind of information the glass manufacturer had, and they show that to insurers. They wouldn't show that to the public. What they showed to the public was more this on the right. Okay. But it was known, and for what I understand, the industry actually adopted this idea of safety probably almost at the same time the legislation was passed, but certainly they were proactive about it. So by the time we reached the late 60s, we have a glass industry that has done all this. They have twisted the glass, they bent it, they curved it, tinted. They even put antennas in it. It's laminated glass, so you can run a wire inside. They put the defrosting, etc. So we reached what you would call a point of synthesis, right? Now let me go back a bit in time, about 10 years. Where is the connection between this and architecture? Well, by the way, laminated glass is what we should use today every single time in architecture we have a problem with safety. We should use it, and we don't necessarily use it. We still hear about falling glass on the streets, and that's simply because we forgot sometimes that this option is available. It's more expensive. I mean, the building industry doesn't even have to be curved, by the way. So. But the link with construction is about how these windshields were connected with the car. So in the moment we had a curved windshield, well, there had to be a different way to connect that to the body of the car. And so suddenly we have this marriage between glass and the petrochemical industry with the introduction of neoprene, rubber. So we have a necessity to have a continuous gasket that can wrap around the windshield. It's a loop. It's something that can be just plugged in around the edge of the glass. This is one option that was used in the Chevrolet, for example. Again, the manufacturers were really concerned about this idea. Glass is a delicate material. You have to be able to replace it. If glass chips, we have to be able to substitute it. So they had manual for the replacement of windshields. And then something else happens. General Motors in the oh, not 81, sorry, that's a typo. In 1961, there was a patent that introduced a new gasket system. So that's a typical windshield show there on the left. Then we have some neoprene gaskets of two profiles, one all around the perimeter, one for the middle strut. But what it does, look at this beautiful drawing from a patent. So you have a gasket of rubber, or neoprene in this case, that plugs into a flange at the bottom, right? So neoprene is a material that if you force it through a piece of metal, it wraps around it, but then it puts some pressure around that and it just adheres to it. It restrains itself on it. the H gasket then takes another gasket that is shown there in a cross hatch, number 12, that zips that gasket. So we have a system that can wrap around the windshield, plugs into the body of the car, and then we can zip it from the outside. How clever is that? General Motors patented this. I mean, I'm sort of cutting it brief here, but there's a genealogy of patent that took to this. 1951, sorry, I was wrong again with the dates there. But I'll show you how that little clever device was borrowed literally into the architectural industry. And of course, LOF, they built their own headquarters. They commissioned Skidmore, Owings Merrill, the office in New York in this case, to build their headquarters. A leading manufacturer of glass in America, let's make a glass box, of course. But let's make it using the latest and most advanced technologies of the time. It's a glass box of double glazing for the times, early, late 50s, early 60s was quite an achievement. And let's do it also using the same methodology of glazing that is used in cars. So the zipper gasket idea, exactly the same. Obviously, it's not exactly the same, as we shall see. There are differences, but the idea was to have a technological demo of what glass could be, and also how glass in their position could be the link between the construction industry, the skyscraper, and the cars at the same time. Of course, glass dominates, so even the details of the time will show you that the air conditioning units are raised from the floor, which was quite an interesting detail for the times, where you can see the glass hitting down the floor. It was normal in those days to have air conditioning on the edge of a building, unlike today. And here we see the construction sequence, which is quite unusual for a high-rise building. If you look at the high-rise today in Melbourne, you find that, generally speaking, builders don't wait until they finish, they reach the top in order to start the facades. Things start to sort of progress all at the same time. But in those days, it was not that obvious because this glass had to be installed using some building maintenance unit at the top. So you see some gantries there, some cranes that were used in order to have some swing stages, and then the glazing will progress from bottom up. Again, this is a close-up of the gantry, so you can see these swing stages coming down from the roof. And this is the procedure of glazing. So a loop of rubber that is fed through aluminum framing with an enormous amount of waste of labor, obviously, right? A gantry that was designed specifically, you can see it's sort of interlocking into the mullions. These loops are fed through. They sort of remind me of someone changing, the bicycle wheel after you have a hole in it. But they are putting rubber through the window. So they are feeding it through the aluminum frame, like that, all around. So these were pictures that were taken by LOF in order to promote this marriage between, the car industry and architecture. And then, of course, the gantry will continue down until this gasket is installed. And then the fun part comes in when, obviously when you get around the corners, that had to be tucked in. But that's not all, because then the glass had to be lifted up. So this was side glazing, double glaze unit, lifted up, put on the gantry on pressure caps, and then fed through this gutter, which is an H-shaped gutter. And then the zipper comes in. So the gutter, once installed, is loose. The glass comes in, and then the zipper ties it, like the car windshield. And so we have now a pressure gasket that is effective and it's working very well. So we have pressure that keeps the glass in place. We have a zipper worker there, and there's a hand press tool that helps in the process. Then the glass can continue. So we have a sequence here. Interesting, an observation I'd like to make. You think about the assembly chain of cars, where you have people generally doing the same thing all the time for the same day. Well, it's interesting, in the building industry, you have a bit of that too. I suppose if you're a glazier, you'll be putting glass all day. But you're moving in space, while in assembly line, the machinery moves in front of you. So there's this sort of more dynamic element of moving in space that perhaps made the job be more romantic, but equally labor intensive. Now, was that a successful method of glazing? Not really. If you look at curtain walls are installed today, we wouldn't dare to do that. Nobody would even think about doing that today. However, the construction industry, and this is where I think it's fascinating, the construction industry got that idea, but they shifted it somewhere else. They put it in the concrete panel industry. Now, precast paneling became very common after the war, as well as as well as other systems of facades. But precast had this obvious problem. You have to put glass, which is a very delicate material, against concrete, which is notoriously hard and imprecise. So what better than the gasket system that was used in curved windshields, where it's plugged in and again it's zipped in order to put pressure around a concrete panel. So this is a patent from Mr. Borsky in Texas. There was other ones. And this is probably the first building recorded anyway in professional journals, where we see this idea of the gasket, but also the unitized panel being lifted up in a building in Oklahoma. And here is the close-up of the system. What you see there on the left is something that was brought, it's from an Australian journal, Architectural Science Review of the day. And Ron Ballantyne, who was a building scientist of the time, used to work for CSIRO, by the way, is the scientist who understood the problem of nickel sulfide exploding glass, for example. So he was an expert of facades, and he showed in an article in '58 here in Australia that he was aware of this method of glazing that General Motors invented. So immediately, almost as soon as this was used in America, in Australia we were following suit. And of course, with the precast concrete market here, it took off quite quickly. Now, this is a procedure I found which is related to the building in Oklahoma. The pictures are not great. It's a number of architectural record of the 60s. But it shows you the same procedure. This time it's done off-site, so it's a prefabricated environment. You probably notice how the panels are curved so that these loops can fit better the curves rather than the ones that were shown in the building for LOF in Toledo. And this finally takes us here. So at that point, in the mid-60s, we have a system to glaze precast panels that incidentally wasn't used for the first time, perhaps a bit with a show-off sort of attitude from a glass manufacturer. But then suddenly the construction industry grabbed and made its own, and it put it in a different environment, in the precast paneling. And notice how, unlike the building in Toledo, this is here in Melbourne, Collins Street, the Royal Insurance Building. A very fine building, by the way, that's underrated. We call it the Black Stump for a period of time, but it was a very clever building that used this technique of zippers, but it used it in a very innovative way. It's using it in the same way we build curtain walls today. So you have glass that is already in the panel, it's lifted up, and look, there's only a few workmen there attending to the task. So whilst it is true that we can have an automotive industry that can inspire the construction industry, I suppose the key message, at least from this case study, is that yes, but whatever it's borrowed will have to be adapted to a very different methodology of construction, which is not the assembly chain in the factory, it's the reverse. Okay, so it's architecture, but also building elements that continuously have to move in space. So the amount of labor, it's different. So that was all. Thank you.